here. We're live.
Brandon. There's Brandon.
Man, that traveling has done a number on him. He's looking a little rough.
Man, when you're always on assignment, yeah, it can mess with you. All right, so it's just me and you now.
You know, Christmas is in a few days, and we are not dressed festively at all.
No.
I almost wore my Game of Thrones Christmas sweater, but I thought I would get too hot. But I'm a little chilly. But I thought I would get too hot.
Well, there's always a hangover.
Yeah. So happy holidays
Hey,
to everyone out there. We hope everybody has a good holiday this week. I'm excited.
Yeah, you've been nothing but smiles for a couple weeks.
It's the most... Okay.
No, go ahead, sing it.
No, copyright.
Oh, well, can't you do like a number of seconds?
That was as many seconds as I'm going to do of me singing. Anyway.
I think you should do like many seconds of you singing.
No.
Yeah.
Anyway.
You can sing Happy Birthday now.
Oh, Jack has no school. Yay.
Oh, yeah.
Yeah, no school.
I think the school next to us is out too.
Oh, good. No kids walking by our house all the time, trampling through our nice, freshly laid snow.
Yeah, they need to... Yeah, get off my damn lawn.
Get on my snow.
Get off my snow.
Get off my snow.
I like for it to be just beautifully pristine.
I know.
So
I did go in there and eventually wipe the solar panels off of those lights, though.
Yeah, I know. You're not helping me.
I held off well. All right, let's get this party on the road.
Are you
ready? Yeah.
All right. Hi, everyone. Welcome to another episode of the non-award-winning Cosmos with Cosmos.
Aww.
Well, last time I said that we were award-winning, you looked at me and what?
We give ourselves our own awards.
Today's episode is Attack of the Killer Space Rocks, also known as Redirecting Hazardous Asteroids, where we're going to talk about the Whistler all day. So that's what we're going to talk about.
Oh, is that what we're really going to talk about?
Yeah, no.
No spoilers.
As always, I'm Mike.
I'm Liz.
And Brandon's not here. Smeagol's here, though.
Smeagol's always here. Smeagol's the best, has the best attendance, maybe, out of all of us.
No,
we could just leave and let Smeagol do the show.
Me, you, and Smeags. We're here every single time. However, there is one person who's not. And they're not here today.
Oh, he's working.
Yeah, he's on assignment. All right, so follow us on all the things.
All the things.
Yeah, all the things. On Twitter, it is Drinking Cosmos. Everything else is Cosmos with Cosmos. And rate us and, tell everybody that you like us and all that kind of good fun stuff. And, yes, Witcher is back. Your mom.
Yes, I know.
Follow us on all the things. Tell everybody, that you love us and that they need to listen to us and watch us and all that kind of stuff. What are you drinking?
Oh, okay. I thought you were going to do rules first.
Oh, okay, I'll do that
but
later.
It's fine. I am drinking in my very special Alaska mug a Attack of the Killer Space Marshmallows. And this is a hot chocolate with coffee liqueur, creme de menthe, and marshmallows.
Nice.
Also made with cashew milk. Because
yeah.
we use cashew milk and not real milk. Or as I like to call it, dirty nut milk.
Yeah. All right. I am drinking out of my actually this is Liz's Blockbuster.
Oh yeah.
The last Blockbuster on the planet cup, silicone cup.
Yeah, I know, they're really nice.
And my cup is over there. But anyway, this is I am calling this the Yarkovsky, which we'll maybe get into later on.
Yeah.
But anyway, it has orange juice, cranberry juice, vodka because it is Russian, named for Russian astronomer, physicist. What else? Oh, Sprite is in here. Lemon juice. No, club soda's in the other one. Okay. And lemon juice. And I think I didn't put cherry juice in this one. So that's what it's got.
Yeah.
Yeah. So the main thing is vodka because Russians, and
they
that's
like
all they
vodka.
drink. All right, so those are our drinks. Let's see, do we have anybody?
Jack's drinking a Nutella latte, which sounds good. You're not a big fan of Nutella, though. No. You don't like the hazelnut?
I'll do it, but it's not, I'd rather have chocolate.
Okay. What are you asking us? Should you get what? Which one? Which of the things are you asking if you should get some? You can let us know in a second because we know there's a delay there.
Yeah. Maybe that was for somebody else. Oh, are you talking about like the cups?
Oh, she has hot chocolate.
Oh, okay.
Yeah. No, you don't have to. I don't know. You can get what I don't know. Anyway.
Oh, the Nutella. Okay. Anyway, so rules.
Oh, cashew milk. No, Mom, you don't have to get cashew milk.
No. we can drink regular cow milk.
We could, yeah. You don't have to get cashew milk.
I forgot we mentioned dirty nut milk.
Oh yeah.
All right, so we got a few rules here. Anytime that a puppy barks and Puppy Jack's feeling a little under the weather, so I'm not sure that he's gonna bark.
Yeah,
but Leia might.
He's got a little tummy. He's got a little tummy ache or something.
Yeah. Anytime there's a Star Wars reference, or if there is a Lord of the Rings reference, which may or may not happen because Brandon's on assignment. But we do have Smeeks here.
Yeah,
he might say something.
He might. Yeah.
If he says something.
I mean, he only says like really like
my precious.
And then like Gollum.
Well, that's Gollum though.
Yeah, but that's still,
He does tell Gollum to get the hell out though, which is a great moment in the movie. Mm-hmm. But when I saw it the first time in Two Towers, there were people laughing in the movie. I'm like, this is a pretty dramatic moment.
He's just telling himself to get the fuck out.
Yeah.
When you think about it. Anyway.
All right, so.
Michael just go out and milk the neighborhood cow.
Well, we do have some cows that are just right down.
But they're of the steak variety.
They are steak cows.
Not the milking variety.
Nope, they are steak cows. All right, so let's talk a little bit about the attack of the killer space rocks, also known as asteroids.
Asteroids!
Yes.
What are they? Where are they? Why are they? How are they? Asteroids.
There's a lot to unpack to all those questions. All right, well, asteroids, what are they? They are the leftover remnants of the solar system forming 4.5 billion years ago. And you typically find them... Go ahead.
Solar system crumbs.
Yes.
Crumbs of the solar system.
Crumbs of the solar system. Comets would be solar system... What would that be? Solar system ice cubes? Snowballs?
Yeah.
Dirty nut milk, dirty snowballs? All right. Anyway, you do find most of the asteroids between Mars and Jupiter, but not all of them are there. No, some actually cross the Earth's orbit.
Uh-oh.
Hence, attack of the killer space rocks, and how we need to be worried about those. Because they can cause some damage.
Yeah, they've caused a lot of damage in the past, which we'll talk more about in the Hangover.
Or whenever.
Yeah, or whenever.
Yeah, I mean, it might be in Oregon that we actually talk about it. But anyway, currently, there are 1,113,527 known asteroids, according to NASA.
Is that in total asteroids, or just the near-Earth objects? Or
it's total asteroids.
Okay, so that includes like Jupiter's Trojans that are hanging out with it, the asteroid belt.
Yeah, that we've actually seen. We've actually seen.
Wow.
Now, estimates, though, are entirely different things.
Oh, okay.
And so Jupiter's Trojan asteroids they think that there are just as many Trojan asteroids as there are asteroids in the main asteroid belt.
Oh.
Yeah.
That's a lot. Well, Jupiter's a big guy.
It is a big guy. But Jupiter's not the only one with Trojan asteroids.
Saturn, right?
Saturn has them. Mars has some Trojan asteroids.
Oh, I didn't know Mars had Trojans.
And the Earth has one.
Wow.
Or at least one that was discovered in 2011.
Oh, really?
Yeah, so maybe we should talk about what Trojans are. All right, so most...
They're fighters from ancient Greece.
Yeah. Yeah, but they lost. They lost out, you know? Mm-hmm. They let the horse in.
I'm seeing the downfall of putting marshmallows in my drink right now. Anyway.
All right, so there's three kinds of... You have different families of asteroids, but we'll say there's three main branches of asteroids.
Okay, three main flavors.
You have the main asteroid belt, which is where most of the asteroids are located. Yeah. Then you have the near-Earth asteroids, which actually are the dangerous ones for us anyway. that cross the orbit and could potentially hit us.
Yeah, they're just coming in for a nice vacation.
Yeah.
You know?
Yeah.
Sample those sandy beaches and see
Water
the sights.
And then you have what's called the Trojans. And the Trojans hang out.
I just saw Jack's comment.
Oh, wow.
I'm just surprised I didn't even think of that. Thank you, Jack.
You almost need to take a drink for that.
You know what? Let's give him that. Let's give him that. Jack, you get it.
Jack's comment is, aren't they ribbed? Okay.
Yeah.
Are you okay?
I took a
marshmallow?
I took a much bigger sip than I should have. And some heat just hit me in the back of the throat.
Okay, so Trojan asteroids hang out in these little orbital regions called Lagrangian points, which is actually kind of important for the James Webb Space Telescope, which we'll talk about next time. And next time being in a couple weeks or something.
Hopefully after it's launched.
Hopefully.
Anyway.
In 2024. But there's 5 Lagrangian points for an orbit.
Okay.
And the L4 and L5, Lagrangian number 4 and Lagrangian number 5, actually are in front of a planet and behind a planet in its orbit. Ooh. And so as the planet goes around the sun, whatever is in those Lagrangian points, they go with it.
Oh, so yeah, okay.
They can just kind of go around with it.
That's cool.
And it's basically a region in the orbit where the planet's gravity and the sun's gravity kind of cancel each other out. So, you can hang out in the Lagrangian points. You don't have to use much fuel to stay there.
Okay,
and so pretty
nice little...
somewhat stable orbit if you're right there at the Lagrangian point.
You gotta be right on it.
Yeah. And so you can find asteroids there, especially with Jupiter. Jupiter's got a lot of these Trojan asteroids. But like I said, Saturn, the Earth has at least one. Mars has some as well.
Yeah. That's cool. But, I didn't know Mars had and it goes so well with Mars having Trojans.
Yeah, that's true. That's true.
Anyway.
All right, so there are 150 of these asteroids that have moons.
Wow.
Which is really, I mean, this is kind of a recent phenomena in that we've discovered this. And not a recent phenomena, but it's recent that we discovered it.
We need to have the technology to see them.
Yeah. I mean, they're hard to spot. They're small, relatively speaking, and so they're kind of hard to spot.
I think my favorite pairing of an asteroid and its moon, because I like just the name of the asteroid, the little asteroid that's in orbit around the asteroid, or it's whatever. I guess it's a moon, is Ida and Dactyl.
Ida and Dactyl.
I like Ida and Dactyl, because I like Dactyl. That's just fun.
It makes me think dinosaurs.
Yeah.
There's a little dinosaur going around Ida.
Ida and Dactyl.
There's a little dinosaur asteroids.
Yeah.
Which is ironic, because the asteroids killed the dinosaurs. Or it helped. Which I guess we'll get into at some point. I mean, we have to. We have to talk about that.
Well, yes, of course. We're going to talk about asteroids just obliterating us.
So they range in size from, a little bit less than 30 feet all the way up to 330 miles across. And Vesta is the biggest of the asteroids. And so Ceres is a dwarf planet, by the way, which is in the asteroid belt.
Yeah.
But Vesta is considered an asteroid, and it's the largest of them. And if you take all the mass of all the asteroids in the entire solar system that we know of, it's less than the mass of the moon.
That's something to think about. Yet, how many of them could destroy us all?
Yeah. What happens to the moon when the asteroid crashes in the Earth? The moon just enjoys the light show.
No. I think the asteroid's moon.
What?
Could an asteroid with a moon? Could an asteroid wouldn't be able to have a moon if it was on a collision course with us? Could it?
Yeah. Just bring it along.
I guess so.
We get hit by both of them.
It's just a weird visual in my head, I guess.
Yeah, because I mean, the asteroid doesn't have a lot of mass, and so for the moon to be, gravitationally bound to that asteroid, it's got to be pretty close to it.
Could the moon miss us if it was a far enough away from its parent
asteroid? It would be extremely rare that would happen. The parent asteroid would have to be a grazing hit on the Earth, and the moon would have to be completely on the opposite side of the asteroid from the Earth for that to happen, for it to miss us.
Would it get like launched around, or its gravity would
it would. Yeah, I actually. It's very hard to see a situation where that would happen.
It's interesting to think about.
It'd be 2 hits, yeah.
Yeah.
Both of them would hit us, and they wouldn't hit us in the same spot. Like the parent would hit. Let's say the parent hits first, and then downrange the moon would hit, and so it.
Oh, that might be the worst kind of.
Yeah, because they're not hitting the same place. Like you might have one hit in Washington D.C. and then the moon will hit.
Talk about a 1-2 punch.
Yeah. Podcast pun master. And then the other one hits like maybe in Europe or something.
I agree, Jack. Little moons should be called moonlets.
Moonlet, yeah.
Deadly moonlets.
Yeah. All right. So,
okay, cool.
So there's not a lot of mass to all these asteroids. So it's not like The Empire Strikes Back, where you have all of these asteroids kind of whizzing around.
Oh, right. Yeah. When they're going through the asteroid field.
It's not like that at all. And I think that the average separation between asteroids is like 1 million or 2 miles.
It's like millions of miles between them. So
yeah, it's not. They aren't close to each other. And so basically, you have 3 types of asteroids. You have what are called the C-type, which are
the rocky ones?
What?
Are they rocky ones?
No, that's the S-type.
Oh.
So the C-type is Crondite asteroids. They're made of clay and silica.
Oh, okay. So they're more of like a dusty type.
Yeah, and they're dark in appearance.
Yeah.
They're the most common, and they are the oldest asteroids of the asteroids. So they.
That's because I'm gonna guess that you need elements made from stars to make some other types.
Yeah, well, that's true. That's true.
So you need to have those stars first before you have.
Yeah, that is true, and you have to have them explode. Yep, gotta have them blow up. The other second type is called the S-type, which is silicate.
Okay, so
stony.
Rocky.
These are the stony ones.
Stony ones. That's right.
But they also have a little bit of iron and nickel in them, and then the real bad boys of the asteroids,
those are
the M-types, which are the metallic ones, which are
those are the hard,
iron
heavy
and
hitters.
nickel.
Those are the steel-toed boots.
Yes, they are.
The solar system, right there.
Those are the types that when they come into the atmosphere, they probably coming down to the ground. They're gonna hit the ground.
Big fireball.
Big fireball.
Big bada boom.
Big bada boom. And so yeah. All right, so we have these guys whizzing around all over the place in the solar system, and sometimes they run into other things. We can look at the moon, and we can see it with the moon with all the craters.
Mercury.
Mercury is covered in craters.
Oh, yeah.
Mars has got a lot of craters.
Mars has got some craters.
We have seen at least comets hit like Jupiter.
Yep, Shoemaker-Levy 9.
Yep.
In 1994.
Sure, 1990s. I was gonna say 1990s. Somewhere between 1990 and 1999.
That's so cool. Because you can see the images and you can see the impacts on Jupiter, but Jupiter doesn't have a surface as a gas giant, so you're basically seeing these impacts in thick gas.
Yeah, but they left like black eyes.
Yeah.
Look up images for Shoemaker-Levy 9 impact on Jupiter, and they really are amazing pictures. And Jupiter's huge, and these are huge marks, black eyes on Jupiter. And just think what would have happened to Earth if the Earth had been hit by all these little fragments. It's an interesting story. There was a comet that was orbiting, and it got a little too close to Jupiter, and Jupiter broke it apart.
Got a lot of gravity. It's like, hey, come here. Get over here.
So it broke it apart, and watching it, we realized that when it came back around, it was going to hit Jupiter. And so all these telescopes and everybody was trained. Hubble was looking at it.
It's like the car crash that we're all trying to see as we drive by that everybody's ready for. We're like, all right, here it comes.
They even had spacecraft at like Mars or somewhere turn and look at Jupiter to watch this happen.
That's fun.
And they just plowed right into it over like a day or two. And so we have impacts all over the place. You have impacts like on Venus, but we can't really see its surface, so it's kind of hard to see, but it also has that really thick atmosphere. There are a lot of craters here on Earth. I forgot to bring up the picture of us at Meteor Crater.
We're going to show a picture of us at Meteor Crater.
Yeah, in Arizona. And so we have craters here on Earth, but these craters don't last very long geologically speaking.
Because the Earth is active. It's got all kinds of erosion, volcanoes, wind, water,
yeah, all kinds of erosion going on.
All that shit kind of just like erasing the evidence of getting 1-2 punched for millions and millions and billions of years. And we do, Mom, know what type hit us during the dinosaur days, and we'll get into that in a little bit.
Yeah, we'll talk about that and how we're overdue for another one of those things.
Spoiler alert, humans were not around during the time of the dinosaurs.
No, they weren't. So, oh God, that's a different podcast. That's a completely different podcast. And so, and actually in the early aughts, actually it was kind of late aughts. I think it was like 2008.
Okay, I was like
something like that. And I can't, oh God, I wish I could remember. There was a telescope, I think it was the Catalina Sky Survey, had found an asteroid, and they did real quick orbit measurements for that asteroid, and they were like, in 19 hours, it's going to hit the Earth. And it did. It hit the Earth, and they, and with the orbits, they were like, it's probably going to land in Africa, and in the Nubian desert, there were pieces of this asteroid.
Oh, and this you could see it clearly because it was in stark the color. It was black, and it contrasted well against the sand, so people could see the meteorites.
Yeah, you can go, and that's why if you're down in Antarctica, that's the best place to find meteorites, because it black on white, and you're like, oh, okay, there's a rock, and you get it. And so they were able to go where it had impacted on the Earth and pick up pieces and stuff like that. It was the first time that they had found an asteroid and predicted it would hit the Earth.
Wow.
I want to say it was in 2008, 2005, somewhere around in there.
Okay. That's
it's in the aughts.
That's a necessary thing to be able to do.
Yeah, and we need to find these things. And to be fair, there are not as many as I would like, but there are people around the world that are trying to find these asteroids and trying to gauge the effect, the potential hazard that it'll have.
Yeah.
So we have people working on telescopes. Again, it's not as many people as I like because this is a big threat to us. And this is something that we can't wear a mask for.
No.
We
might end up having to wear masks and become mole people, though.
Yeah, that's true. That is true. But there are some things that we can do to potentially not get killed by these space rocks.
Okay, that'd be great.
Yeah, I know, right? And all we need is 7 minutes
of terror.
All right, so let me explain the 7 minutes. Okay, so the Earth is going around the sun, so it's constantly moving, right?
Yeah.
If you have an asteroid that is on a direct collision course for the center of the Earth, right in the middle, going to hit bullseye right in the middle.
All right.
It just needs to arrive 7 minutes early or 7 minutes late, and it will miss the Earth. Because we're going around the sun with a certain velocity.
We're moving, and so we basically can dodge it then.
We can dodge
essentially. We're just like, what?
Yeah. Yep. So when we look out and we discover this asteroid is coming and it wants to kill us,
and we all scream in terror.
Oh shit! What are we gonna do? We just need to nudge it a little bit.
Oh, okay.
Now,
just a nice
little bit.
Hey, hey, buddy. Could you just
move over a little bit?
Scooch a little
bit?
We were here first. We're just saying. Can you just...
Yeah, can you just one seat over? That's all I get.
Pardon me, sir.
Have any Grey Poupon?
If you may. A little to the left, please.
Now, the hard part, though, is actually moving these asteroids.
Giving it that nudge?
Giving it that nudge. That's the hard part.
I assume it's not just a tap on the shoulder. It's got to be a little bit more
No, but
than
you
that.
can tap it. Boom, tap it really hard.
Yeah.
That's actually one way of doing it. It's not a little tap. It's a big tap. So there are a few ways.
No, we need to give the old 1-2 punch back.
Yeah, we do.
I'm just going to reuse the 1-2 punch this whole episode.
Yeah, and you know what?
We've already done like 5 times.
That's fine. That's fine. Okay, so it all kind of... oh wow.
I have the power.
We are on a dome.
That's weird.
That is really weird.
Send us a picture of it. Look at it.
Oh my god. Okay.
I love it.
All right, so I wonder how many people are listening to us. Did you sell tickets?
He hasn't muted.
If you sold tickets, we have to get a cut of this. I want some money. It's Christmas time.
Yeah, you're right, Mom. It's not polite to bump into us.
No.
It's rude.
No, it's not. And so there's different ways in which you can do this. It all really kind of boils down to when you discover it. 19
How
hours.
How much time you have?
Yeah. 19 hours is not enough time to do shit. You're just going to have to endure and hope for the best.
Unless we have, okay. Here's an idea. Straight from you first here at Cosmos with Cosmos. We take our nuclear missile silos, and instead of filling them with nuclear weapons, we fill them with a different kind of nuclear weapon, already ready to be launched to space to go bump an asteroid out of the way.
Yeah.
Not explode it. We'll get into that later. But just, a spacecraft, they're already prepped and ready to go.
Yeah.
So that it can be like, oh, we got launch. All right, cool.
Yeah, that would be nice.
Program some things in, and then...
Yeah, instead of sending a nuclear missile to Russia or something, we send it to space.
Yeah. And then we're already ready. We don't need to worry too much about the time limit unless it comes from the direction of the sun and we can't see it and it hits us immediately. That would
be really nice. It would be really nice. The problem is, we got neighbors here like, no, we got to blow up Russia.
I thought you meant the immediate end of an asteroid coming from the sun and hitting us, and I was like, I guess it would be nice.
We actually will talk about that probably in the hangover.
Yeah, we'll talk about that. But yeah. Anyway.
Okay, so one of the ways in which you can do it is actually to use these nuclear missiles that you're talking about.
To just nuke it.
Yeah, you can just nuke it.
So the Bruce Willis effect.
Yeah, except
how are we not? I was wondering how long it was going to take before we made a Bruce Willis reference. To be honest.
Yeah. All right. So here's the thing about nuclear bombs. Nuclear bombs, they give you a big boom.
Oh, yeah.
And let's be honest,
they look cool. They look real cool.
They will work at moving the asteroid. They will work, but there are some problems. Okay. First of all, you have a type of asteroid called a rubble pile asteroid. It's not like a solid
it's just
metallic one. It's just kind of this loose collection of pebbles, basically. Pebbles that are big rocks.
It's like a shotgun shell filled with little bits and pieces of things.
Yeah, pretty much. And if you explode a nuclear bomb on or near it, it's a little difficult to deflect those.
Shrapnel.
Yeah.
Just shrapnel everywhere.
Now, what they do try to do, though, is they would want to explode the nuclear bomb above it, not on it or inside of it, but above it. And what that does is the neutrinos and X-rays that come out of that explosion will kind of vaporize the top layer of that asteroid and maybe give it a little bit of push.
Oh, so it's just another way of just bumping it.
Yeah. But for these types of asteroids, rubble pile asteroids, it's not It's a little bit difficult. It's not the most efficient way of doing it. Rubble piles are kind of the worst nightmare of asteroids.
Now, how easy is it to distinguish between an asteroid that's a rubble pile and one that's more a cohesive rock?
Oh, well, that's good. I mean, the metallic ones are going to be solid.
Yeah.
I'm thinking that probably for the S-types, the stony ones, you could probably pretty much guarantee that it's going to be solid for the most part. But, I mean, you can look at it. You can look at its density.
Mm-hmm. How much time do you have to figure that out? How long does it take to figure out those
I think
aspects?
You can probably figure out that stuff relatively quickly. Okay. And so it's... the density's the main thing.
We wouldn't be able to use the ISS. Because we can't actually fly the ISS to like a destination.
Yeah, if you're using ISS, it's too late. Especially if you're using a drop bomb.
Yeah. It's a little bit too close. ISS is, how far away is ISS?
It's something like 300 miles.
Yeah, we don't.
It's pretty close.
Yeah.
A little too late at that point. You can also explode a nuclear bomb on the surface, and that might push it. You can actually hit it with a nuclear bomb, and that will make a crater on the asteroid, and then have another nuclear bomb go in and explode inside that crater, and it kind of acts like a rocket nozzle and gives it a little bit more of a push. And so that's one way of doing it. Now...
Okay.
Here's the problem with Armageddon. Okay.
I don't want to close my eyes. I don't want to fall asleep.
That was a comet, though, wasn't it?
Yeah, because it had, right? It was like there was all this vapor when they were on it.
Yeah.
Or they were just, their science wasn't accurate.
No, so they exploded this nuclear bomb, and... That was an interesting movie summer because you had Armageddon and Deep Impact both came out at the same time. And so I think Deep Impact had Frodo in it. Anyway.
Why did they name it Deep Impact?
Because it hit in the ocean.
I mean.
Well, yeah.
Couldn't they? Anyway.
All right, so and I want to say that, like... in Armageddon, didn't it like cleave it in two and these?
Yeah, and then they just went to the Earth. They just went.
Yeah.
And missed shaved the sides of the Earth. Meanwhile, rain fire of hell down upon all of life.
First of all, you're not gonna get that. They didn't get that nuclear bomb right in the middle of that comet to split it in two. And that is such a nice little cleave right there. But I want to say that if in Armageddon, you watch the two big pieces go past the Earth and miss the Earth, but you also see impacts on the Earth occurring.
Oh yeah.
So those are now radioactive little pieces of stuff that are impacting the Earth.
Because of the oh man.
Yeah, because the nuclear bomb.
And those impacts are actually pretty big. They're gonna do some.
Yeah, the nuclear bomb is actually. The byproducts of nuclear bombs are neutrinos going everywhere. Neutrinos, yeah, but neutrons going everywhere. That's going to fuck up somebody's DNA. You're going to have these X-rays going everywhere.
So basically, the ending of Armageddon is really just everybody got cancer and died anyway.
Well, on the impact sites, yeah, probably.
Well, I wonder how. Okay, anyway. This could be a far deeper... impact than we need to get into.
Yeah. Now, having bitched about nuclear bomb, I much rather have take my chances with those little
than nothing.
With those little pieces of radioactive comet shit coming down than the whole thing. And so
yeah.
So nuclear is that
is a we have no other option.
Yeah.
Call the Willis family.
It really is that we have no option and this is what we got to do.
Call the Willises and the Damons.
Yeah.
To combine forces together.
Yeah. And of course we need Arwen. Do we have to take a drink?
Oh yeah, because you said Arwen. If you just said Liv Tyler.
We need Arwen, crying at the TV as her dad blows up. He didn't feel anything. He didn't feel a damn thing when that thing went off. It's like 1 second you're here, next thing you're just atoms. So we thought COVID was bad. Yeah, well.
It's bad in a different way. There's apples and oranges.
Yeah, that's true. That's true.
We could do something much faster about COVID.
Yes, we could. All right, so how about other ways in which we can do this?
Yes. Nukes. Last resort. What's better?
Kinetic impactors.
That sounds fun.
Yeah, so we were watching this thing, and I think I was looking at something on my iPad, and I guess they said kinetic impactors.
They did, and I got really excited. I was like, kinetic impactor, that's cool.
And I was like, oh, look, it's right here. I got it in the thing.
Hold on. Bruce Willis was invited to the DART launch by NASA, and he declined it?
Why did he decline it?
Never meet your heroes. Just kidding. Because he's probably like, I'm sick of this fucking asteroid shit.
We're going to get into DART right now. So, kinetic impactors, just think of these as big old friggin' car crashes. That's really what they are.
So next time we see a car crash,
kinetic impactor.
Hey, check out that kinetic impact.
We're not going to remember it.
No.
Or if we do, is one of us will remember and go kinetic impactor, and the other one's going to be like, what the fuck?
So it's like instead of using a nuke as an impactor, you're using something else to hit something.
Right.
To hit it.
Right. And we actually have a mission called the Double Asteroid Redirect Mission, DART.
Why is it double asteroid? Oh, because it's a lobed asteroid?
No,
that it's gonna hit?
Actually, is it a lobed asteroid? I don't know, but it's hitting the moon of this asteroid.
Oh, so it's an asteroid with a moon.
Yeah, this is an asteroid with a moon.
Oh, okay.
And that's probably the double.
Okay, yeah, that makes sense now.
Anyway, they just launched DART.
No.
Like a week or two ago?
Oh, no, it's supposed to get there in September of next year. Okay.
October.
Well, in the thing we watched, it was September, so did they push it back?
Okay, well, in October of 2022, according to what I found out. It could be September, though. Okay. It will impact with the asteroid's name is Didymos. Yeah, sure.
Didymos? I'm sure. Okay, obviously it's named after some Greek god or thing or.
And so sometimes the moon's called Diddy Moon.
Diddy Moon. Diddy Moon.
Makes me think Diddy.
We can call it A Diddy.
Yeah. Diddy Moon. Dimorphos is the moon. Dimorphos.
Dimorphos?
Yeah, it's just easier to say Diddy Moon.
Diddy Moon.
Diddy. And so it's going to impact it, and it will change its orbit around Didymos. Dimorphos, yeah. The moon's orbit will actually change.
Okay.
The moon itself is about 600 feet across, and so this impact will change its orbital dynamics, and the next time it comes by the Earth, we're going to have all these like radar and telescopes and stuff like that are looking at it to see exactly how the orbit has changed.
Wow.
And then we can, fine-tune things as to how in the future if we need to do this.
This is the future.
Yeah.
We're in the future. I mean, we don't have flying cars yet, but...
No.
I mean, we do have things that fly.
And one of the important things with hitting this moon is that you're not knocking the moon out of its orbit,
causing another issue.
Yeah, and you're not changing the orbit of the parent object.
Okay. So then that I guess that impact, that kinetic impact on the moon doesn't.
Yeah,
so the parent, it's not enough for the main parent asteroid to feel it, essentially?
No, it'll change the orbital dynamics of the of the asteroid itself, but the center of mass between the two is going to just continue as if nothing happened. And that's the important thing, is that you want that center of mass between the main asteroid and its moon to continue unaffected. Okay. And that's what's going to happen. So,
not our moon's orbit, the moon of the asteroid.
Yeah, so Dimorphos, its orbits will change, and Didymos might change a little bit relative to it.
Wait. Is Didymos the asteroid or the
Didymos
moon?
is the main asteroid.
Okay, Dimorphos is the moon.
Dimorphos is the moon.
So it's called, but Diddy Moon because
Moon.
Okay. I was. I'm glad we got that.
So it's so it's very important that you don't mess it up so that like it comes in.
Don't fuck with the mama.
Yeah.
Don't wake mama.
Yeah, because the last thing you want,
asteroid.
The last thing you want is for the actual asteroid Didymos to go, what did you just fucking do? And then change his orbit.
Did you fucking shove my kid?
Yeah, and then come down. I'll show you.
It's on.
Meanwhile, the Earth would be like,
what you got after mammals, Earth?
Roaches. Roaches survive everything. That's what's after. That's what's after mammals. Asteroids spin though. I know we've talked about this before, like like black holes spin. Earth spinning.
Is there anything that like doesn't rotate?
No, and anything that isn't rotating is really. It can happen, but it just is so unnatural in this universe. Everything's spinning.
In motion.
Yeah.
We're all in motion. We're getting weirdly out of focus on our end, but whatever.
Yeah, nobody wants to see us in focus anyway.
I'm moving too much. I'm in motion too much for the camera.
It's all that coffee.
It's all that cosmic brew I've been drinking.
So these impactors don't really work really well with things that are spinning. And so you might need some other things to do it. And there's another method called tractor beam.
Hey! I wonder where that idea came from.
From Star Trek, but guess what? Or Star Wars. No, actually Star Trek.
A Borg cube is still fictional, hopefully. So...
Oh my God.
Enterprise doesn't spin.
Don't you have a job to do, Brandon?
He's on break from assignment.
You're on assignment, dude. And when are we going to get this? You're supposed to do like a video report about what you do on assignment, and we have yet to get our...
Your report's overdue.
Anyway. Yeah, so this thing called tractor beam. And we don't actually... shoot a tractor beam.
Okay, I was gonna say, like, what is it? Are we just throwing like grappling hooks at it and just kind of?
No, but actually, there actually is a. I don't have it on the list of things to do, but or ideas, but there is one where you can attach a solar sail to it.
Oh, and use solar power to maneuver.
Literally, yeah, solar power to kind of push it out.
Okay.
Now, this tractor beam thing, you need long time. Long lead times. This is
like when we're like, all right, guys, in 5 years, this asteroid's going to hit us 100%. Yeah. So let's get building.
Yeah, so you need some time for this to happen. And really, and all you do is you take a really massive spacecraft, something that's pretty heavy, and you just park it off to the side of this asteroid, and you have some fuel so that it always stays the same distance from the asteroid, and you just use gravity, the gravity of this little spacecraft, which is incessant. It continues. It's relentless. It will pull on this asteroid and eventually change its orbit. Again, all you need is 7 minutes. That's all you need. You just need it to arrive early or late by 7 minutes.
7 minutes.
Yeah, and so you need a long time for this because the spacecraft gravity is really quite weak.
I mean, how long is it going to take for it to pull it?
But asteroids aren't all that massive either, and so
what is the metal one?
Well, I hope it's a small one.
Okay, use a different method.
Use a different method. Method 1 or 2 might work better with those.
All right, so methods determined by the class of asteroid you're dealing with.
Yeah. Related to this is something that they call the ion beam shepherd, where you...
IBS.
Oh, that's... I didn't even think of that. Now I'll never see it otherwise. Okay.
I mean, look, this is a space stuff. You got to think about those acronyms.
Oh, you do, right? And so this is where you actually put a smaller spacecraft and park it above the asteroid, and don't use gravity to change its orbit, but you turn its rocket nozzle towards the asteroid, and it's just constantly battering it with thrust, and it always stays at the same height above the asteroid, and that thrust gives it a little push.
So it's just like it's like when you see a car breakdown and they use another car to help push the car out of something or in a direction. Yeah.
I mean, yeah.
Okay.
But that second car is using like thrust to push it.
Yeah, that's what I'm saying. It's
we're gonna turn our exhaust pipe towards you and push you out of the snow.
Yeah, I meant the front of the car.
Yeah.
Its nose, because you said the nose of it.
Oh no, the rocket nozzle.
Oh.
The rocket nozzle.
Oh, okay.
No, it's the rocket nozzle that would do it. Your mom asked a really good question. Can we change its spin for these asteroids that spin fast?
I mean, I assume we could.
You can.
If you can move a moon into a different orbit.
Yeah. No, you can do that, but you are going to expend so much more energy trying to stop it spin, and then.
So the spin isn't really
No, that's Yeah, you're not gonna want to try to change its spin just because you're gonna use all this energy just changing its spin only to come in and have this gravity, this tractor beam, quote unquote, change its orbit. You might as well just actually hook a rocket up to it and not change its spin, but just kind of try to shoot it out. But well, that's not going to work either. Yeah, you're not going to be able to really... You can change the spin, but it's not the most ideal way. It's not the most ideal way of doing things. And again, this is a slow to change the orbit type thing. These tractor beams and IBS, irritable beam shepherds, to just change the orbit. But again, you just need 7 minutes is all you need. And it's possible. It's just that you need time. And gravity and the thrust of a rocket will do it for you.
Good old gravity.
And this is actually one of my favorite ones.
Oh.
It's now called focused solar energy.
Oh, that's what it's called now?
Yeah. But it was I think it was the Planetary Society. They gave it its first name, which is Mirrorbees.
Mirrorbees.
Yeah.
That sounds so cool.
It does. So basically, you put these mirrors above the asteroid, and it's like a swarm of these mirrors. It's not just one; it's a swarm of them, and that hence the bees part. But the mirrors will.
You couldn't get near this; they would kill you.
No, they would kill me. I'm allergic to those things. It would focus the sun's light onto a point, and if you ever take a magnifying glass.
So it's basically the kid with the magnifying glass versus the ant.
Yeah, let's not do the ant. Let's burn a hole in the leaf because the leaf will actually show it. But if you take the if you take the magnifying glass and focus the light.
You chose the leaf because we didn't want to kill the ant. And let's be nice to the ant.
Well, I don't want to kill the ant.
Okay.
But if you focus the sun's light onto the leaf will smoke. It's the same kind of thing. What you do is you focus the light from the sun with these mirrors onto a point, and it will vaporize that rock. It'll get so hot it actually vaporizes, and when you vaporize it, it gives a little thrust, And so it pushes it. It's like a little tiny little rocket engine.
Little tooth. Oh.
Continuous stuff.
Yeah, how much time would it take the Mirror Bees to move the asteroid 7 minutes off its orbit? You could choose asteroid mass and composition at random.
Okay, all right. So this asteroid has a mass of 1 kilogram. So not long. In fact, we won't even have to worry about it. It vaporizes it.
I feel like it would take a long time for
It takes a while.
And I feel like maybe that's not the most... It feels like it's just fancy and not the most efficient method to where something else could accomplish a similar effect.
Okay, yeah. I mean, a nuclear bomb can do it pretty quick.
Yeah.
You know? But...
I mean, without exploding the asteroid.
An impactor probably...
But, like, the kinetic impact seems like that is going to do the
same
thing faster, you know, so then why even bother with the beams?
Well,
because you got to make those mirrors and...
Option 1 and 2, kinetic impactor and nuclear bombs are your quickest and probably most efficient way of doing things. However, you're not always going to want to have a nuclear bomb go off and irradiate stuff.
Well, sure.
Also, nuclear bombs, you really kind of need to do it right. You don't want to explode the asteroid, and then you have multiple asteroids that you have to worry about.
You need some finesse.
You do need some finesse. And nuclear bombs are not known for finesse.
Yeah, no. I mean, why not just, like, bump shit into things?
Yeah, I mean, kinetic impactor, but you need to test this, and that's the whole DART thing.
Oh, well, yeah.
And actually, the physics behind a kinetic impactor is a little bit... you're going to know the end result much better than with a nuclear explosion.
Yeah, I was going to say the physics seems pretty sound that... Yeah. You know how much mass and thrust and force you need versus...
Right, but also some of this shit doesn't work with rock pile, rubble pile asteroids. Nuclear bombs aren't as efficient with rubble pile asteroids as they are with...
okay, but something like ones. The Mirror Bees maybe would be.
Maybe, potentially, yeah.
Okay.
But, yeah, so... I don't think that they're probably going to use Mirror Bees all that often. It's really going to be nuclear bombs and it's probably going to be kinetic impactors. Is probably what it's going to be.
Well, yeah, because they want to save the nuclears for their wars.
For Russia or whatever, for the corporate wars that we have. Lasers are really kind of cool too. Lasers can do the same thing.
Yeah.
Space lasers.
Space lasers are always cool.
Yeah, and basically you just have a laser. Then you don't even need the sun. You have a laser, shoot at a point, it vaporizes the rock.
A Death Star, but for good, and not for evil.
That's no moon. Oh, is that it? Oh, Star Wars.
No, that's not a...
No, that's no moon.
That is. That. Oh, I got nothing left.
You can
This
have...
is going to be a weird mix.
Yeah, well...
My mom asked, so we'll have something in space just being prepared for a deadly asteroid? We should.
We should, but we don't. We don't.
Yeah, and DART, and something like DART specifically, that's basically launch and goodbye. Yeah. It's not something that's wouldn't be in space just waiting for the moment to go.
No, it's on its way to kill itself, basically.
Yeah, it's basically it's a... I don't know if I don't want to use that reference. Never mind.
Okay. Well, I mean, this isn't the first time that we've actually used a kinetic impactor on an asteroid. The Deep Impact mission actually hit an asteroid with basically a metal ball. And it was not going to change its orbit. They did not want it to change its orbit or anything like that. They just wanted to see what would happen.
They could hit an asteroid with a ball.
Yeah, and they also wanted to see what would come out. And there was a lot of cool shit that came out of the asteroid, and they were able to do that. But Another way in which you can get rid of an asteroid,
get rid of it. Hey.
Change its orbit is to actually.
I need you to get rid of it.
Is actually paint it.
Oh yeah, paint. Graphiteroid.
Yeah, graphiteroid. Yep. You can paint it white, and that increases its reflection, and so the radiation pressure from the sun will kind of nudge it out.
Okay.
Again, need long timelines for this. You can paint it black, and you get this thing called the Yarkovsky effect, which occurs. Actually, it was this one.
Oh, it was that one.
But
they don't know.
Yeah, I know, right? The Yarkovsky effect, and we experience this every day. Every day. We are getting most of our radiation from the sun, our sunlight, at noon. It's directly overhead, but it's not the warmest time of the day. The warmest time of the day typically is at 2 o'clock, 3 o'clock. It's a couple hours later. And that is when the Earth is irradiating most of its infrared.
It's releasing,
Yeah. The same thing goes on with an asteroid. So if you paint it black, it's receiving all this energy at noon. However, at 2 o'clock, 3 o'clock, it's releasing that energy, and that energy for small asteroids gives a little bit of a push.
It's got a little gas.
And if the asteroid is in what we call prograde rotation, which means it's rotating it's counterclockwise like everything else in the solar system, it will have the effect. Nice reference, Brandon. I see an asteroid. I want to paint it black. Paint it black by who's the guy from? Was that the Rolling Stones or CCR? But anyway. If it's in prograde motion, so counterclockwise, it will have the effect of making the asteroid's orbit a little bit larger. If it's going the other way, then it will decrease the orbit.
I don't want that one.
And make it small. Well, no, as long as it misses us by 7 minutes.
That's right.
That's all we need.
That's right. And
7 minutes.
The reason why pretty much everything in the solar system is rotating counterclockwise is because the solar nebula that formed our solar system was rotating counterclockwise. So everything kept that rotational pattern except for a couple wonky things, like fucking Venus.
Yeah, and which is probably upside down from an impact. Yeah, and you know the cool thing about impacts is okay.
What's the cool thing about impacts?
There's really two types of impacts when it comes to impacts in the solar system, in the universe. You have the actual impact that we all think about. It's the car crash. One thing literally runs into another, makes a crater, kills dinosaurs.
Oh, we don't want it. We just want to see it. We don't want anyone to die.
But you also have what are called gravitational impacts. And these are when you have an object get really close to another one, but not actually hit it.
But its gravity is like, hey!
And its gravity pulls it over. And like for Venus, we'll flip it over. For Uranus, tip it over on its side. And those are gravitational impacts. And can you imagine that fucking day? We're just hanging out, and all of a sudden this thing comes around and knocks you over.
What would happen? What? Maybe we should say that for the hangover.
Oh, what would happen to us?
Yeah. And how long that time would take, and what would happen to us? Let's ruminate on that for a minute.
Oh, gotta take a drink.
Oh. Dog bark.
Here.
Yeah, thanks.
And you know what? That actually is the perfect ending to the show. Stay with us for the hangover, where we talk about some of the impacts that we've occurred and answering your questions about impacts and things like that. But in the meantime, if you're not hanging out with us, have great holidays. Happy New Year. The James Webb Space Telescope, in theory, launches on the 24th. So hopefully that is 5:20 a.m. I did say hangover, didn't I?
You said hangover.
All right.
Brandon's trying to get under my skin from several hundred miles away.
It's supposed to launch at 5:20 a.m. Mountain Time. That's when the window opens. Doesn't mean it'll actually launch then, but on the 24th. So it'll be a great Christmas gift if we can get it up safely. But speaking of safely, stay safe, stay healthy. Do not drink and drive.
No.
And everybody have a great holiday season and Happy New Year.
And watch out for asteroids.
And watch out for asteroids. Oh, in 2 weeks, on January 2nd, we will have a James Webb recap. And if it doesn't launch, then we will talk about something else.
We'll just do something else. All right, we'll see everybody. Thanks for joining us. Bye. And we'll see everybody else in the Hangover in a bit. We will be right back.
Hangover? How's it hangout?
Oh, my God. Hey.
We're back.
Apparently, for James Webb, everybody will just gather in our room and watch it.
I really doubt that will happen,
No.
but okay. All right. Or we could all meet in the living room.
Yeah, or the exercise room.
In the exercise room, and there are options.
Yeah.
I'm pretty sure Katie and Adam will not be joining us as they sleep until noon.
No.
They're vampires.
They're vampires. Poe's a vampire. She bit them, and now they're vampires.
She bit them?
No, I'm just...
Oh, okay. No.
Anyway. That's their cat. Anyway, for those of you. All right,
Potato.
Welcome to The Hangover. In the main episode, we were talking about asteroids and asking them not to hit us.
Please don't hit us. Please.
And the various methods to avoiding asteroid impacts.
Mm-hmm.
What
was the question that came up?
And the one that I want to go into with the hangover?
Yeah.
Basically, if an asteroid had a close approach and gave us a little gravity tug and flipped over and flipped the Earth over, what would happen?
We would be dead.
How fast? How long would this take?
Really quick. Really quick. Well...
Would gravity be the same, or would we just all fall down real hard?
Okay. That actually is a good question. All right, there's different things in this. All right, okay. First of all, to flip the Earth, you need to have a pretty massive object. Do this. So another planet-sized object.
Okay, which we don't have any asteroids that big enough in our solar system, luckily, anymore.
And all the planets are basically in stable orbits, and we do not have to worry about this.
This kind of thing would have happened to Venus and Uranus during the early solar system formation, when you have a lot of larger objects flying around. And a lot more planets than the 8 official planets that we currently have. So anyway. Earth is falling and can't get up. So you have this massive object that comes by. It's got to get pretty close to the Earth to actually flip it. We won't even go as far as Venus. We're just going to say Uranus. We're just side topple.
Halfway. We're going to do it halfway. We're going to half-ass this.
Half flip.
We're going to do a half flip. So this thing has to get pretty close to us. So most likely, I bet your weight does change. You are going to feel a gravitational effect from this. So you won't...
Are insides coming out of outsides?
No. God, no. No, we just kind of lift up a little bit. So your weight's a little less. Good diet plan.
It sounds fun.
Temporarily.
Until we come back down.
Yeah, the problem is that when you flip, the atmosphere does not flip with you as quickly.
Oh,
and so
would we be exposed to?
No, we won't be exposed. We'll always be up underneath this blanket of air. However, that blanket of air will rub against the Earth.
Oh, it gets real hot.
So you're talking about winds that are thousands of miles an hour.
Oh my god.
And you're talking about
basically
friction.
Up will still feel like up, because we're still in line with the center of gravity on Earth.
Yeah.
That center of gravity of Earth isn't going to change. Up's going to feel like up. Just all of a sudden, we're just going to get just crazy butterflies in our tummy, feel a little lift, and then just be incinerated.
You'll be incinerated, but also...
and be like, it's windy.
There's going to be earthquakes, volcanic eruptions. Basically, the REM song, It's the End of the World as We Know It.
Wow.
It starts with an earthquake, birds, snakes, airplanes.
Wow.
So...
Why has nobody done a sci-fi movie on this topic? I mean, they would have, obviously, the science all wrong, because someone would need to live for there to be any movie. There'd have to be a core group of survivors.
Yeah.
But it would be a fun, dramatized concept.
Yeah, there would be no survivors to this. It would be, 1,000 miles per hour hot winds, sounds like Oklahoma.
We wouldn't know what Oklahoma winds are like.
No, but but yeah, even if you go underground, and so you're sheltered. That's not
going to be stable because the ground's going to move.
The ground's going to move a lot. There's going to be a lot of shaking. And these are going to put the greatest earthquake that we've ever had to shame. What if you were
in a plane? You get the winds, right?
Well, remember, these are surface winds. These
Okay.
are surface winds, but yeah, it does lead to turbulence. So the Earth is just rapidly spinning beneath it, or flips beneath it, and that's going to create these eddies in the atmosphere, which the plane is going to experience. So you get to watch it happen for a couple seconds, and then you get hit by the turbulence, and then your plane disintegrates beneath you.
Now, what about if you're on the ISS?
Oh, if you're on ISS, you actually... Well, that planet-sized object is going to disrupt your orbit.
Okay.
So it kind of... You're fucked. You're fucked no matter what.
Okay. What does the view look like for the ISS? Are they just going to be like... Well, we were looking at, North America, and now we're looking at China.
Well, yeah, maybe kind of, yeah. Yeah, but they're going to be affected by this planet-sized object too. And this is quick. It's not like it's a slow motion wreck.
Yeah, well, how long does it take for the Earth to go whoop?
Because if it is a slow motion wreck, that means that planet-sized object really is going slow enough that it's actually going to hit us.
Okay.
So this needs to be a very fast thing. It needs to be a very fast thing to occur. You basically need this rogue planet come out of fucking nowhere, and go past the Earth extremely fast, but fast enough that it flips us, but not slow enough in which it actually
hits us.
So, yeah, that actually is fun to think about. It's not fun to experience.
But what a dramatic way to go out, though.
Yeah, so Brandon says ejecta probably would get the ISS too, but remember, it's not an actual impact, so there's no ejecta.
So there wouldn't be ejecta.
There's no ejecta.
It's just,
This is all gravitational. This impact is all gravitational.
Wow.
If it actually hits us, oh, fuck the ISS. We're
we're
all done. And the Earth has another moon.
Fifth element kind of object. There you go.
Yeah, so, that's a fun mental exercise.
That was fun.
But we have had a lot of impacts.
We have
in our history.
Well, yeah, I mean, everything in the solar system has, because you had the early and late heavy bombardment periods where all kinds of shit's flying around and hitting another ship before it gets cleared out.
Yeah.
Either, through impacts making things bigger, or, the solar wind igniting and blowing out all the littler stuff.
The littler
stuff.
All right. So why don't we talk about some of these impacts?
Are smart.
It's like the Packlets. We are smart. We are strong. All right. So in lieu of questions, if anybody has questions, so I don't think we have a question right now.
Oh no.
How many Skittles? A meteor crater size. Oh.
Crater.
God damn it! Why didn't I think about
that? So it's a mile-wide crater.
Oh, it's not.
Behringer's a mile wide.
It's a little smaller than a mile, I think, or at least according to what I read this morning.
Okay.
All right. Anyway,
we'll round up.
42 Behringer
Skittles units.
42 meteor crater Skittle units of Skittles. We'll fill it. Anyway, let's talk about some of these impacts until we get another question that actually happens.
All right. Yes, these impacts.
Let's talk about meteor crater. Meteor crater is also called Behringer crater. It's located in northern Arizona. It's a little bit east of Flagstaff, a little bit west of Winslow, Arizona, where if you stand on a corner, they'll write a song about you. And it was created about 50,000 years ago. So...
I got an itch.
Liz has an itch. All right, so meteor crater, created about 50,000 years ago. When it's a little less than a mile, but let's just say it's a mile across.
Okay, we'll say it's a mile.
It's about a mile across. Is about 560 feet deep. The rim itself lifts up above the crater about 150 feet.
Yeah, it's crazy. I recommend visiting it. It's your perception of scale gets totally kind of messed up.
Yeah, and it's just an amazing thing to just be on the edge of and to experience and realize this was created by something from outer space. Please do not do it again in my lifetime, but this was something. And 50,000 years ago, the asteroid that made it, 160 feet across. That's it. 160 feet across.
That's it.
It came in at 29,000 miles per hour.
Coming in hot.
The effects of this asteroid would have been hitting the Earth would have been felt in Flagstaff, which is like 30-40 miles away. And so just anything around it would not have survived.
Yeah, no. And it actually was an impactor, right?
It was an impactor, okay. Yes. It was an iron meteorite that impacted. But half of that meteorite was vaporized, so it was actually much bigger before it actually hit the ground.
Okay.
About half of it vaporized in the atmosphere.
Okay, yeah.
And 160 feet is left over, so it was about 300 feet across when it actually hit the top of the atmosphere, and creates this little less than a mile wide crater on the Earth.
It was just lonely. It was looking for a kinetic connection.
But it made a kinetic impact.
Those often lead to kinetic impacts.
We really have to remember that every time we see a car crash. Kinetic impactor! Who was the initial kinetic impactor? I bet it was that car. When it snows, there are a lot of kinetic impactors.
Oh, yeah.
So that was only 50,000 years ago.
It's not that, it's a long time ago, but not that long ago in comparison to the age of the solar system.
Yeah, and asteroids that are 160 feet across, they impact the Earth about every 764 years. Yeah, so we've had quite a few probably. Now, most of those probably are impacting in the ocean.
I don't like that.
No.
I don't like
Oh, but wait.
I don't want to. Okay, we're gonna.
It's gonna get better.
Oh, jeez.
It's gonna get better.
Okay.
Okay. So what are some of the other impacts that?
Well, should we do the most famous one, and get that out of the way before some of these minor ones?
Are you talking about the Sudbury impact?
I'm talking about the Chicks. Chicxulub, the dinosaur killer.
Yeah.
Exterminator, actually.
It occurred 66 million years ago, and it wiped out 75% of the planet and animal species on the Earth. 75%.
That's a lot. That's a lot.
It is a lot.
That's a lot. It gave way to us being able to evolve into our kooky beings.
It's a good thing and a bad thing, I guess. Mixed bag. Yeah, it killed the dinosaurs, but it did lead to having mammals really kind of take over the world. I say take over the world. Insects really own the world because there's many more insects.
I wouldn't think that. Can we please get the spider over our TV? I can't.
Okay. Well, I was like, let's suck it up with a vacuum cleaner, and you're like, no, because then it's in the thing. No, and
then I said okay, and you can go and get it with the vacuum cleaner.
All right, I'll get it today.
Okay, thank you.
It basically created a 100-mile wide crater in the Yucatan Peninsula, so down in Mexico. And it really, like you said, just wanted to experience the beaches.
I was looking for a vacation. It's like, this planet looks nice. Somewhere I can relax.
Yeah, it was basically a 6-mile wide asteroid that hit the Earth. And do we know why alligators survived?
They were in the water. I'm sure alligators do not look exactly how alligators looked.
No, I do think that.
I'm sure.
I want to say that the smaller you were, the better chances you had
to survive.
The Chicxulub crater is the second largest crater that we know of on the Earth.
Second largest. And it wiped out the dinosaurs.
The largest one occurred 2 billion years ago. It's located in South Africa, and it's about 186 miles across. And the asteroid that made it was upwards of 9.3 miles across.
Whew.
Yep. So, really quick,
big,
asteroids that are 3 miles across, they have a frequency of hitting the Earth. You can't look at this.
Okay.
The frequency is about every 20 million years. Long time, right? Long time. Last one we know of was Chicxulub. So we're overdue. We're overdue. So what was a day like? What was a day like for those asteroids?
Day.
It was a normal
for the
day.
asteroids?
No, for the dinosaurs.
Okay. I was going to say for the asteroids, also a normal day. Except
it was suicide mission.
Except this blue marble just kept getting bigger and bigger. Until it was like, oh, there's some things here that I'd like to say hello to.
Yeah.
For the dinosaurs, it was just a normal day. Everything's just eating their things, killing their things, doing their stuff. And then I'm sure some of them probably looked up and were like,
oh, shit. Huh. That's bright. We have 2 suns now.
And then nothing. And then it was just, and then the ones, that were still around after the initial impact, just starved or burned or froze to death.
Yeah, so there's actually, I think there's a book. There's a book that actually they go into the day the dinosaurs died, literally the day.
Oh yeah.
Yeah, and so at least the excerpt or the recap that I read talks about how the asteroid comes in, it hits, and it hits in the ocean. So within minutes, you have these mountain ranges that are created. It's the rim of the asteroid, hundreds of miles across, and within minutes, mountains are made. The ocean water gets kicked out, obviously, right?
The seas were parted.
The seas were parted, so creates these amazing tsunamis that go out and ravish the world, right? Mm-hmm. That they crash upon Mexico and North America, or at least what was North America at the time, and that type of thing. The water then flows right back in and fills in a lot of this crater with debris and all this kind of stuff.
Dead dinosaurs.
Dead dinosaurs. Well, if there really kind of are any at this point, but dinosaur carcasses and things like that. Trees, all kinds of what used to be alive just moments earlier, and molten rock raining down miles and miles away from this impact.
I love a nice molten rock rainy day.
Yeah, and so, but also this asteroid was rich in sulfur and created this sulfur haze that blocked out. So it was a very bad day on day one, but those that actually survived, the tsunamis, the liquid rock rain that rained down upon everything, the fires, the forest fires that just ravaged everywhere. They then had to deal with basically a nuclear winter.
Yeah.
And as a kid, they were like, hey, Russia could attack us at any time with nuclear missiles, and it would create this nuclear winter, and we'd all freeze to death and shit like that. And the dinosaurs lived that until they didn't live it anymore. But then again, the upside is it allowed mammals to thrive and eventually led to us, and then we're just going to kill ourselves. So, Here, Asteroid, hold our beer. We're gonna
don't
do
wear
this.
your mask, everybody.
Yeah.
Wow, what a shitty day.
That is a shitty day. That is actually a day.
Next time you're having a bad day, just think about the dinosaurs on their last day. I've never seen the end of the 90s show Dinosaurs. I used to like that show.
Oh,
I've never seen the end
You never
of
saw
it.
the end of it?
No.
I don't think I ever saw the end of it either.
Brandon posed a question earlier saying, I wonder if atmosphere density makes any kind of difference. For example, if a 100-yard asteroid hits the Earth, would it have the same crater size on Venus?
The atmospheric density effects. So the short answer is no.
No.
The crater on Venus, if it actually even hits the ground, is going to be much smaller, because the atmosphere.
Oh, so then it does. The atmosphere does make a difference.
Would it have the same crater size on Venus? That's why I say no.
Okay, but his initial question
All
was,
right.
Does the atmospheric density make any kind of difference?
Yeah. So question
yes.
number 2. Question 1, yes. Number 2, no.
Okay.
So the atmosphere the atmospheric density is going to cause friction to occur on the asteroid as it comes in.
Yeah.
And so the thicker the atmosphere, the
More
greater chances.
Power, basically?
Or exploding power.
Oh,
What's going
okay,
to end up happening is it's going to heat up quicker and it's going to disintegrate or
explode in the atmosphere, much like Chelyabinsk
Yes.
in Russia.
Yes. And so if it does hit the ground on Venus, it's going to be much smaller.
Because there's less.
Yeah.
Okay,
I will tell you that a 100-yard asteroid is most likely not going to hit the ground on Venus. Yeah, it's not going to hit the ground on Venus. It might here. 160 foot. Remember, 160 foot.
I don't know
asteroid.
what a yard is. I'm just picturing like a meter stick and then imagining what.
Okay.
100 of them are, and it doesn't seem big to me because I don't know.
100 yards on 100 yards is 300 feet. So you're bigger than Behringer.
Oh, okay.
You're bigger than meteor crater
Okay.
at that point.
What's 300 feet equivalent to in something I can visualize?
A football field.
Oh, okay. All right.
100 yards?
I don't know how many yards are the 50-yard line. I don't know.
A football field.
Okay, thank you.
All right, so that's probably for us the most famous one because it's tied to the dinosaurs, which we all love dinosaurs.
We all love dinosaurs.
We don't want to be in a pen with dinosaurs, but we love dinosaurs.
Spoiler alert! I got Christmas dinosaur wrapping paper.
All right, I'm trying to read Brandon's saying.
The top of the atmosphere to the ground is such a short distance in comparison to the speed of the asteroid. Didn't know how much that thicker atmosphere would affect that space rock.
Right, but the atmosphere does, obviously, because we have Chelyabinsk where the thing exploded. If we had no atmosphere, Chelyabinsk, the Chelyabinsk meteor would have hit the ground and become a meteorite.
Which we wouldn't care about because with no atmosphere, we wouldn't be here.
Yeah. So the atmosphere does have an effect. Now, if it's a 6-mile wide atmosphere, asteroid, no. I mean, seriously, a 6-mile wide asteroid, the asteroid hits the ground and the top of the asteroid is above where planes fly. And so it's very thin atmosphere up there. So for a 6-mile one, probably not as much. But for something like Chelyabinsk, it does have a major effect.
Yeah.
Now, Chelyabinsk, and I know I'm not saying it right, but Chelyabinsk is just an absolute crazy fucking story.
Oh, yeah.
February 15th. We knew an asteroid was going to pass us that day, and it was going to be pretty far out. It was going to be relatively close to us, but it was going to be beyond the moon's orbit, so it was going to be out there. So we knew it was coming. We were all expecting it, and we were all excited. I mean, because near Earth, when asteroids fly past the Earth, as long as they don't hit us,
we're like, hey!
it's kind of cool. It's kind of cool. And all of this. I woke up on February 15th, and Twitter had exploded. It was insane. There was so much shit going on about this asteroid. And I was like, wait a minute. This
is not the right asteroid.
This is too
soon.
What?
This is a different one.
What had happened was that in the early morning hours for Russia, so overnight for us, this asteroid came in from the direction of the sun. We had no idea it was coming towards us.
Blinded by the light.
Exactly. And it exploded above Chelyabinsk, Russia, which is in Siberia, and about 18 miles up. And it was I think they finally settled on it was like a 66-foot asteroid. But at the time, it was like, we think it's 60, which was perfect for us because it was the size of our dome, our planetarium dome. And so I was able to say, hey, look, this is...
This is the size of it,
This is the size of it. And there's incredible video of this. This
is when we learned about dashboard cams.
Yeah, and at least in the prevalence of it in Russia. Mm-hmm. Russia, pretty much everybody has dash cam cameras, and for their cars because there's apparently so
many kinetic impacts.
Fake kinetic impacts, where people try to say, "Oh, you hit me." But then the dash cam says, "Oh no, I didn't."
Yeah.
But there's all this great video showing it come across, and there's like these workers that are shoveling snow or something, and it comes and it brightens the day like midday.
It's beautifully terrifying.
But what really is crazy about some of these videos is that there are videos of this eerie silence of people that have just taken out their phones and started just videotaping the sky, and you can see the trail, and it's just quiet. It's beautiful, and then the sonic boom hits, and glass shatters, and you hear, and it rains down on these people that are filming this, and you hear all this screaming and yelling and stuff like that, and it was just an amazing, in a video, it's an amazing view of the power of nature, or the power of the universe. Really, is kind of what it is. The explosion that occurred for this, 33 times the power of the explosion of Hiroshima in 1945.
So if it wasn't coming in at such a steep angle or a shallow angle, if it was coming in a lot more steep of an angle, by Chelyabinsk.
Yeah, and that actually was what saved it. It was a very shallow angle, and so the shock wave wasn't pushed down onto the city. If it had come in at a very steep angle, straight kind of like straight down onto the city, it would have flattened the city. 1,500 people were injured. Nobody died. And to the credit of the Russian government, the Russian military, the military basically swooped in and erected. This is in the wintertime. This is in February of
in Siberia.
2013 in Siberia. And they erected all these makeshift places for people to stay and stuff like that. But what is really scary is that, yes, this is a local event, but it was almost a global event, because there was a moment where the Russians thought that we had exploded a nuclear bomb over Chelyabinsk.
What a weird target to go for. First of all, what strategic value would there have been?
Yeah, and but still, there's that moment, and you know that like generals and stuff, they have to think that way, but there is that moment where they think, hey, we're under attack. So I Google asteroid passing Russia. Sure, you could do that, or just Chelyabinsk 2013, and you should be able to get lots of video of it.
Yeah. My mom asked, do some go through gas giants? They are gas, right? So, in the main episode, we talked about Shoemaker-Levy 9, which is a comet that impacted Jupiter. So, the thing with gas giants, though, is they are made of gas. However, like, it gets real dense the closer you get to the center of gravity of a gas giant or its core, which is most likely has some sort of solid form to it that we're learning.
You don't even get that far down.
But it gets really dense. So it's not like the gas giants are like clouds that you can just
Yeah, you can't
go through.
You can't fly through it. And so if you were to fall into the atmosphere of Jupiter, the atmosphere gets denser and denser. It also gets hotter and hotter.
And incinerated.
And eventually you get stuck.
You get stuck and incinerated, and it's
Yeah.
not a good time, actually. I'm sure. I wonder how pretty it would be, though. Would you see different colors?
Oh, it'd be gorgeous.
Would you see different colors?
It'd be a great way to go out if you had to.
Go out?
If you had to go out. I mean, if I'm going to commit suicide, that might be a good way to do it.
All right. Just go to Jupiter.
Or that, fall into a black hole and just see what happens.
Oh, yeah.
Yeah, like a supermassive black hole where I can pass through the event horizon safely, and then whatever happens after that.
All right. You fly through space and time and end up in a library or something, an office. I don't know.
Interstellar. Yeah. So should
that was the reference.
Yeah. All right.
All right. So we got Chelyabinsk. We got a Chicxulub killing the dinosaurs. We got a Barringer crater.
We don't have to go through all these, right?
I know, but I do think speaking of Russia, because the planet, our planet, it's a decent sized compared to us. I guess you could say, but only 3% of the Earth is habitable for humans, and the majority of the Earth is water. So a lot of impacts impact the ocean, far away from civilization, and any large land masses that are sparsely populated, like Antarctica or Siberia. And so another impact that's very famous happened in Russia.
Don't go to Russia.
Don't
go to Russia or Australia.
In an area known as Tunguska.
Tunguska.
And this is a fun one. I think this is a fun one. Because Tunguska happened in 1908, and it was not an impactor.
Nope.
It was another asteroid that exploded in the air. And what happened was it did come in at more of a steep angle, right? And so when it exploded in the atmosphere, it flattened all the trees around it, 80 million trees for 830. They're standing, and then they're like.
Yeah, it did two things. It stripped them of their vegetation, and then it just laid them down.
Yeah.
Violently laid them down.
And one old guy got knocked off his rocking chair. According to legend. I don't know.
According to legend. Yeah, and it's just 830 square miles of these flattened trees.
And they're all going in one direction because that force of that impact, you can't have them all kind of in. They're all
in one direction.
Think of a crop circle.
In one direction away from the quote-unquote impact.
Yeah. And that is just crazy.
Yeah, you can literally, by looking at the trees, exactly where it exploded overhead.
Yeah. And there's images of the trees, aerial views of the trees laying down. And so that's another really, really cool one to...
And this was from an asteroid that was 150, 200 feet across. It was most likely a stony asteroid that did this. It exploded about 3 to 6 miles up above the ground, so really not that far.
No.
It got pretty close. Seismographs picked up the impact all across Europe and Asia. And the air blast from it could be felt as far away as Washington, D.C.
Wow. They're like, whoa, what?
Yeah.
Random breeze came in.
I know, right? There were actually people. This is in Europe that would take. They took pictures at midnight where they did not need a flash because of the glow of Tunguska. The glow of Tunguska provided enough light where they didn't need to use a flash.
Wow.
And the glow was seen for a couple of days, and it's actually from high altitude ice crystals that were formed from the impact itself. And where else do we see these? Interestingly enough, from, well, not anymore, but from space shuttle launches. The space shuttle could create these as well.
That's cool.
Mm-hmm.
And explosive.
Exactly. Yep.
Yeah, no one lives in North Dakota or what's the other one up there?
Oh no,
Montana.
Yeah, let's see. I wonder how many impacts have happened in North Dakota. There was actually a big. Because we watched it this morning.
Mm-hmm.
There was an impact that occurred in North Dakota. I don't remember which one it was.
Was it in North Dakota?
Yeah, but the effects were as far away as like Minnesota and stuff.
I thought that was in Canada.
Oh, I thought they said North Dakota.
Maybe it was like.
They went through so many of them.
North Dakota, that's true.
But yeah, so, and actually, you know what? You find a lot of craters that are like in Russia, the higher latitudes and such, like Russia, and then Antarctica.
Well, and I assume because all the this you could, I know you're going to tell the answer, and this is me, my brain just going like, let me figure it out first. Because the planets, they orbit the solar system in a plane, but then a lot of times you have like these asteroids that are coming in, they're going to hit us, they're off the plane, they got funky orbits, so they're not going to be aligned with like the equator mostly. They're going to be lined up mostly with those higher and lower.
Exactly. They're
I knew a thing.
You deduced it. They're not on a direct collision course to the center of the Earth. They're going to be either a little bit above it or a little bit below it, and most likely, in most cases, they're going to probably miss it. I mean, remember, it's just 7 minutes, and so you're going to have most of these kind of towards the higher latitudes, north and south. I would lower latitudes for south, but anyway, closer towards the poles.
Wow.
And you actually see this mapped out. Now, granted, there also is a lot more land mass in the northern hemisphere right now, so you do see a lot of the craters.
More of it, yeah.
But you do see them lining up, at the density of the craters increases as further you go north. But also, like down in Australia, there's quite a few. There's a reason why most likely the biggest asteroid ever impact is in South Africa. It's well, back then, 2 billion years ago, it might not have been really south, but that is actually where you find them, closer to the poles.
So live closer to the equator.
Yeah, just move to Hawaii. I would love to live in
that's a
Hawaii.
small target to hit in the middle of the Pacific.
That is a small, but you know what? It's the tsunami that gets you.
Oh yeah, the tsunamis.
It's the tsunami that gets you.
You know.
And so, like, you know, with like Deep Impact, the movie where Morgan Freeman is president, you know, there's just make Morgan Freeman president or God. I mean, I know they've already done that in movies.
Just have him narrate all of life. It will just calm us all down.
I should get him the script of my life now so he can narrate it. Okay. That way, when I pop off, I can just do the recording.
You can pay a cameo for that, maybe.
I'm pretty sure I can't afford it, but maybe for Christmas somebody can give me that. Yeah. But yeah, I don't even know. Oh, the asteroid impacts and Deep Impact were in the middle of the ocean and created these tsunamis. Right. And so Frodo, with his girlfriend on a motorcycle, gets up to the top of a mountain and just survives.
All right, the
tsunami.
Sure. Of course, plausible.
Yeah, the tsunami from the Chicxulub.
If only he had some eagles.
Oh. Where are you, Brandon? The tsunamis for the dinosaur impact were like 300-400 feet high. Those are massive ass fucking waves.
Tall.
Those are huge. Those are huge. And that's probably in the middle of the ocean. And so they get higher as they, approach land.
My mom asked, is our gravity minutely different at the poles?
No, if you were to go to the North Pole,
same.
It's the same.
It's the same.
Yeah, it really boils down to the fact that most of these asteroids and stuff, they're not on a direct collision course for the equator.
Yeah, they're not in line. They're not necessarily in line with the plane of the solar system. They're on, their orbits around are tilted.
Yeah, so the equator really is the safest place to be when it comes to impacts, but, depending on the size of the thing, we're all screwed, potentially. If it's 6 miles, we're fucked.
Call Bruce Willis.
Yep. And you know what? You can call Bruce Willis all you want. It's not really going to do anything. But
if it's 6 miles, because it's larger, we would have a better chance of detecting the larger it is.
Oh, yeah. Death is coming. We just
don't have time to do. Unless, as we talked about earlier, we have the nuclear silos instead filled with asteroid, deflection shit.
Yeah, and you're going to need a lot of nuclear bombs for a 6 mile wide asteroid. To be honest, it's not going to be one nuclear bomb that's going to do it.
It's going to be...
You're going to need multiple ones.
A lot. What if we use all of them?
You know what? Right now, I just think that would be nice. A world without nuclear missiles would be a great place.
Yeah.
Would be a great place to live. Chelyabinsk, its asteroid happens once every 60 years.
Oh.
Yeah.
Okay, that's...
So we don't have to see that for a while.
But
again...
it's that angle.
But again...
The angle will kill you.
Yeah. Literally. We are overdue for that big one.
For that big one?
That big one.
We're also, we're overdue for a very big
earthquake.
Earthquake. We're overdue for Yellowstone. We're overdue for a big asteroid. We're overdue for a lot of things that are basically extinction level events.
Meanwhile, we're arguing about fucking masks. And whether
but
to get
my
shot.
freedoms!
Freedoms are irrelevant if you're dead. They mean nothing. And let's just be honest. If you don't get a shot and you die of COVID and you did it because of your freedom is not what we're talking about after you die. We're talking about your stupidity. That is what we're talking about. And so you can get on your high horse about freedom and all this kind of stuff. Whatever. You are potentially making other people sick, and you just need to get off your high horse. If you do not get a vaccine for COVID and you do not have a valid medical reason to do it, you're an asshole. That's really what you are. And, go fuck yourself, basically. Just do it in isolation, away from everybody else, because you don't need to get them sick. Thank you for letting me get on my soapbox.
There you go. Okay, well, that was fun.
You brought up COVID, freedom.
Did I? I guess I did, didn't I?
Well, you said something. So maybe we should go make a pizza.
Yeah, I think that's good. I think we've
call
had
it
fun. I think we've wait, we forgot.
Oh, Apophis.
We forgot Apophis, the bringer of death, or nothing.
Or nothing. It's the latter. All right, so Apophis, actually, there was a 3% chance it was going to hit us. And everybody lost their shit. Like, 2029, we're all going to die. And so Apophis is an asteroid. It's an asteroid that's about 1,200 feet across. So it was a big one. And these impacts occur basically once every 100,000 years.
Okay.
I don't know if we're overdue for that one or not.
Probably.
But on April 13th, 2029, which is...
a Friday!
Friday the 13th. It was, at least initially, they thought it was going to impact the Earth. There was a 3% chance it was going to impact the Earth. Turns out it's not.
0% chance.
0% chance.
0% chance. But people are going to lose their minds because it's Friday the 13th and an asteroid's getting close.
And it's going to pass us basically 20,000 miles above the Earth.
That's pretty fucking close, though.
That is really close.
Really, that's like... maybe could you pardon me, sir? Can you please move
yeah.
a little further?
So the moon is 250,000 miles away. So it's less than 10% the distance to the moon. It is actually inside the orbit of some of our satellites.
It's not a danger, but it's uncomfortable.
It is uncomfortable. And it like I said, it's inside the orbit of some of our satellites. That's how close it's going to be. But it's not going to hit us. 0% chance. It's
going to be fine.
But it is going to be a magnitude of 3.1. So what does that mean? That means that actually if you're in a dark location, you can see it with your own eyes. You do not need a telescope. You do not need a binoculars, set of binoculars, whatever.
You do not need an eye aid.
You do not need an eye aid. You can see it with just your own eyes. Because the magnitude 6 is the dimmest that we can see from Earth.
With a dark sky, though.
With a dark sky.
A very dark sky.
But if you happen to have a pair of binoculars, you'll be able to see it. And pretty much every telescope on Earth is going to be trained on it. They're going to be looking at it.
Oh, yeah. They're going to be tracking that shit.
And there was a question of is it going to impact us the next time it comes around? Because it's coming really close. Its orbit's going to be changed, and no, it's not. It's not going to do it.
Okay.
However, this approach is so close that its family is going to change. Right now, it is what we call an Aten asteroid.
Aten. I think they're going with the Egyptian Aten.
Okay, Aten asteroid. But it's going to pass us. And when it passes us, it will change to the Apollo family of asteroids.
Oh.
Yeah, it's going to completely change.
It's a new family.
Yeah, it gets a new family.
Good for it. That's fun.
So, in seven years and a few months.
My mom asked, could we practice nudging it? Could we give it a little boop? Hey. Boop.
Well, I think that... since we know that it's not going to hit us anytime soon.
Well, yeah, but maybe just for the future, just like a little, hey, let's just be a little proactive and give it a little
nudge out there. But the problem is that if you do go boop to it, it might actually hit us next time around. So if you know that in the next, say, 100, 200 years, which is really about 100 years as far out as how you can, that is as far out as far as accuracy goes, that you can be. I would not change its orbit.
Oh. I figured we would be able to we'd have the science down to boop it to where we know what its orbit would end up being.
Well, I mean, but again, 100 years is as far as you can get.
Oh, okay.
For asteroids.
Well, that seems like it's not our problem anymore then.
Well, you know what? That's been our fucking motto for centuries. I know. Ain't our problem. This whole climate change thing.
Fuck it.
Fuck it.
The future will figure it out.
I love my grandkids, but you know what? They can worry about it. I'm pro-life, too.
Why we get all southern when we're talking about it?
Because it's typically, let's be honest.
This is my southern.
Let's be honest. It's the South.
Okay.
It's a southern thing. Anyway, weren't we going to just kind of
we're going to end the episode. Yeah, we're going to end the episode.
I'm going to let you call it a day.
All right. You're going to let me call it a day?
Mm-hmm.
I'm calling it a day, folks. Anyway, thank you everyone for joining us on this episode of The Hangover with Cosmos, talking about our potential doom and the various ways we can avoid it. We're overdue for a lot of things, but we are weirdly good as a species at surviving. Like, there's so many things I think about that we've been through our history that I'm like, we should definitely have gone extinct at some point. But here we are, just, doing our thing. So
And I do think that if there were a lot of if we knew an asteroid was coming, that was going to impact us, we would all come together. And
it would be dramatic, I'm sure, and there would be
the first thing that some people would say, let's nuke it. But that might not be the best course of action. No. It probably will be the only course of action. But
we'll see.
Yeah.
Anyway, joining us next time, January 2nd, we will be hopefully doing a recap of the James Webb Space Telescope that's set to launch on Christmas Eve, December 24th, at least here according to our time in the U.S.
Yeah.
Yeah.
I mean, it's 5:20 in the morning our time.
Yeah, 5:20 in the morning.
So
Mountain Standard Time.
Even for Hawaii, it's like 1:20 in the morning.
Yeah.
But
in the meantime, we hope everyone has a great holiday and
Happy New Year.
Happy New Year. We'll see you next year. We'll see you in 2022. All right, bye.
Bye, everybody. Stay safe.
Fun.
Stay healthy. Cheers.
I have to take my time. I can't.
My
mouse is
take
Bluetooth.
Your time. We'll see you.
It takes like a minute.
We'll see you in a couple of days. At least some of you will see in a couple of days.
All right, goodbye.
Goodbye. We'll see you. Christmas. All right, The Witcher. The Witcher